Well, here we are, guys, page 772. Are you there? 772. We're taking our review, chapter 11 review test. Well, not really a test. We're reviewing together. Anyway, go to page 772, 772, 772, and we will go right to it. If you're not there, you know what to do. You know the procedure. You pause your video until you get there. Here we go. Number one. See if you can do it by yourself. We're going to do this one together because I don't like this one. Draw lines to show thirds. For some reason, they always give us a rectangle and a square. They never give us a circle. Circles are more fun to do thirds because you do a Y or a peace sign. With these, you have to estimate what a third is. Ay, ay, ay. I'll show you one way you can do it. Let's see. So there's like 4 centimeters, almost 4, like 3.9, let's say, centimeters in this thing. And I want to do thirds, so there's 3 equal parts. That means each part has to be a little bigger than 1, because if they were each 1, it would be 3 centimeters. So we want a little bit bigger, like 1.3. So I'm going to go to my 1, and I'm going to go to the third line after the 1. That's 1.3. That means this one's about 2.6. That's going to make thirds. Maybe a little too big here. There it is, thirds. 1/3, 1/3, 1/3. This one's even harder. How big is this? This one is close to 24. If I think of this as a 2 and this is the 4th line, it's like 24, 2.4 centimeters. So if I divide that into 3 equal parts, I get 0.8. So I want the 8th line. Now this is the 10th line, so I'm going to go back to 9, 8. Right around there. And this one will be about the 16. Here I go. Here I go. And these are about 1/3 each. 1/3 is hard to do. Explain how you know the parts are thirds. Well, they're thirds because why? There's 3 parts and they're equal spaces. They're equal. They're about equal, and there's 3 of them. That makes thirds. If there were 4, it would be fourths. Or if they weren't equal, it wouldn't be thirds. They have to be more or less equal. Okay, Will and Anna. Try this one by yourself. We did this one before. You should be able to do it by yourself. Go ahead, read it. Oh, you know what? Pause your video and do it, because I don't want to be waiting a whole long. Okay, did you do it already? Did you pause and do it? Will and Anna have gardens that are the same size. They're the same. They're like squares, and they're the same. They each divide their gardens into fourths. What are 2 different ways they can divide their gardens? Draw to show your answer. Well, one way would be to draw lines down like this, except instead of 2 lines, I would have to do 3 lines. I would cut it in half, and then cut it in half, and cut that in half. And that would be fourths. That's one way to do it. Another way to do it is to do the diagonals. On a square, you can do that, but on a regular rectangle, on a non-square rectangle, you can't. But if it's a square rectangle and you do the diagonals like this, the vertices, you connect the vertices, it makes 4 equal triangles. So they're all 1/4. So that's one way to do it. Another way is I can cut this in half. Now I can measure it and cut it. It says 3.2, so about 1.6. Right around there is the middle. So I can cut the middle like this. Now, I could cut the middle here, and that would be fourths. Or I can cut this middle. So I'm going to do 1.6 here, too. About 1.6. Make this one straight. How's that? That's pretty good, huh? That's pretty good. 1/4, 1/4, 1/4, 1/4. You know, my mom used to cut her sandwiches like this into quarters. But when we had grilled cheese, we would cut them this way. Go figure. Actually, we would cut them. We wouldn't do this line. We would only do one line, and we'd have a half a sandwich. But there were big triangles for grilled cheese. Big half triangles, not like this. Okay, draw to show halves, thirds, and fourths. Color a half of, a third of, and a fourth of the shape. Okay, they put a circle. Oh, but they wrote the word halves. Dang, let's change it. You know, these people made these books. They're no fun. We're going to make this our thirds. And we're going to change this one to halves. Actually, you know what? Let's change this one to fourths. And I'm going to change this one to halves. I'll tell you why. Because the thirds, first of all, I'm going to do my Y third. So I put a dot in the middle. I'm going to make a straight line down. Right? Now I want to make a Y. I'm going to make it to about there. And so this one has to be about there. That looks about right. Okay, let me see if that works. And these are 1/3, 1/3, 1/3. That's why you don't see what I'm doing at all, do you? Anyway, I'm changing these. Cross these out. We are not going to do that. We're going to do our thirds on this one. Thirds. This one I'm making my fourths. Now I'll tell you why. If I want to do fourths, I cannot do my vertices because the triangles will not be the same. I'll have a long, thin triangle and a short, fat triangle. They're not equal. I can't do fourths on this one with the vertices, but I can do fourths on a square. I am going to do fourths on a square. I can do the vertices. So that's why I'm picking the square to do my fourths. These people don't think. So I'm doing my fourths on the square. Right? Halves. Halves. Well, just do vertice halves. You can do it on a square or you can do it on a rectangle. Halves are easy to do anywhere. There's halves. 1/2, 1/2. So I switched which ones. I didn't do halves here. I did thirds. I did my fourths here, and I did halves over here. Okay. Let's see if you can finish that one. Okay. See if you can put a number answer down here, okay? Well, this is a tricky one, so the key word here is estimate. Estimate means you're kind of guessing, okay? You're not really going to draw and figure it out. It says to estimate, so you're going to kind of guess by looking at it. Okay, so let's think about this. Max wants to cover the rectangle with colored tiles. The tiles are this big. Explain how you would estimate the number of square tiles he would need to cover the rectangle. Okay, one way you can do it is say, suppose I wanted to just cover the top. I've got one here. How many more do I need? What do you think? One this size would be about here, right? And then you need one more. So how many on top altogether, including this one? 1, 2, 3, right? How about the bottom? What do you think? 3 again. because this space is the same as that space. So you probably need 1, 2, 3 here. So you need 3 on top, 3 on the bottom. How many is that? 3 and 3. 6. Is that what you got? Now, we did not draw because we're estimating. Estimating means you don't work it out, you don't use numbers, you don't draw lines, you take a guess about how many. You look and you say, well, that's 1, so I need another one here, but it won't cover there, so I'm going to have to put 1 over here. That's 1, 2, 3. That means I need 3 on the bottom because it's the same as the top. 3 and 3 is 6. Do you see how we did that? Am I going to write how to explain it? No, this is not writing class. I know you're going to say, oh, but the children have to know how to express themselves. They have to know how to put into words their mathematical thoughts. Oh, you know what? Try teaching math and see how much time you're going to waste teaching writing. Anyway, here we go. On we go. Jenna. Try this one with Jenna. See if you can figure out how to do this one. We didn't do one like it. But you got to be able to look at a new problem and figure out what they're saying and how to do it. Okay. Jenna built this rectangular prism. They're talking about this. She built this. This is a rectangular prism, not this. She built this. Circle the number of unit cubes Jenna used. They want us to circle how many we need to make this. Well, let's look. Look at the top layer. How many are on the top layer? 1, 2, 3, 4, 5, 6. There's 6 on top. So how many are on the bottom? 6. So you got 6 on top and 6 on the bottom. What is 6 and 6? 12, right? 1, 2, 3, 4, 5. Well, that's good. If this is a 5, then what is 2 rows? That's a 10, right? We want 12. So if this is a 10, how many ones do we need? We got 1 10, we need 2 ones. So here's a 10, and here's 2 ones. Circle the number of unit cubes. Well, we need the 10, right? We need the 10, and we need 2 more. So I'm going to come down here, but I'm not going to go there for the 10. I'm going to get the 2 more. There we go. Now I can always count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Ta-da! I didn't have to count because I said this is a 10 and this is a 2. 1 10 and 2 ones is 12. Try this. It's using this word toothpick. Do you know what a toothpick is? It's un palito. It's a little stick that looks like this. And you use it to clean food out of your teeth. You stick it between your teeth to get the food out. That's a toothpick. A toothpick. You think this is a hard one or an easy one? It's really an easy one if you know your shapes and you know what they're asking. Let's read. Rachel makes a pentagon and a quadrilateral with toothpicks. She uses 1 toothpick for each side of a shape. How many toothpicks does Rachel need? Well, if she's using 1 toothpick for each side, then a toothpick is the same as a side. So she's making a pentagon. How many sides to a pentagon? 5. 1, 2, but we're using toothpicks. 3, 4, 5. There we go. 5 toothpicks, 5 sides, because each side is a toothpick. What's a quadrilateral? Do you remember? A quadrilateral is a figure with 4 sides. Oh man, you didn't even see where we are again. Yeah. I got to remember to look at my video when I'm doing it. Okay, first she makes a pentagon with toothpicks. So I used 1, 2, 3, 4, 5. Each toothpick is a side because she uses one toothpick for each side. So there's 5. A quadrilateral has 4 sides. Now, if they're toothpicks, you assume they're all the same size. What shape is she going to make? A rhombus. It's going to be a quadrilateral, but since they're all the same size, that's called a rhombus. A quadrilateral is 4 sides that are the same. A special rhombus would be this one, a square. A square is a special rhombus where they got these corners, 4 corners that are the same. Here the corners are big and the corners are little. A small angle and a big angle, but here the angles are 90 degrees. They're all the same, 90 degrees. Anyway, 1, 2, 3, 4, 5. 1, 2, 3, 4. What is 5 and 4? 9. Because a pentagon is 5 and a quadrilateral is 4 sides. And toothpicks are the same as sides. So it's 5 and 4, 9. Is that what you got? If you did, you're getting on the ball. You're right there. Well, we are already done. 16 minutes. Actually, it's longer than I thought. Okay, already done. We're almost done this. Look at what's all this writing? Oh, it's STEM activities. That means we're at the last page of the book. Monday we get to finish the book. Well, kind of finish the book. We're going to do these later, maybe. I don't know. It looks like they want a lot of writing. How's that STEM? STEM. You know what I think? You know what I want? I don't want to say stuff. I don't want to be impolite and say all this stuff. Anyway, we do have to go back and do these crummy chapters on measuring. But, oops, did you hear me say that? I didn't say they were crummy chapters. These. Well, I have nothing good to say. I shouldn't say anything at all. Goodbye.